Okay, in this chapter, we're going to be doing rational expressions. So that's going to be fractions. We're going to be doing fractions with variables. Before we start that, though, we are going to just do a little quick review of our factoring once again. So number one is the difference of perfect cubes. What's weird about this one is that the variable's at the back end. So you can factor it with the variable at the back end. So this would be 4 minus x times 16 plus 4x plus x squared. So we could factor it like that. If you don't like the variable at the back end, you could rearrange it and write it as a negative x to the third plus 64. But then I would probably factor out the negative sign and go x to the third minus 64. And then go ahead and factor that, and you'd have x minus 4 and then x squared plus 4x plus 16. So those are equivalent answers. Either way, you could write it. The only difference is you've got this right here, 16 plus 4x plus x squared. That's the same as this parenthesis, x squared plus 4x plus 16. The only difference is right here with the negative sign out in front. So 4 minus x is the same thing as a negative sign out in front, so negative times x minus 4, so equivalent. So if you don't like to factor with the variable at the back, you can move it to the front. Sometimes it just saves a step in this chapter if you can factor with the variable at the back end, but if not, you can always move it to the front. Okay, so this one is the difference of squares, so I'll factor it just the way it is. Once again, the variable's on the back end. This is 3 minus 2x and 3 plus 2x. And same scenario, if you don't like it on the back end and you want to rearrange it, you can. Just remember to bring the sign with it. You can't just switch the 4 and the 9. You got to take the sign that's in front of it. Factor out the negative sign. And then factor again, 2x plus 3 and 2x minus 3. So these are equivalent. They're saying the same thing. And the last one is factoring by grouping. So I'll group the first two together and factor out an x squared. So that leaves with x subtract 3. And now the last two, the only thing that's common is a factor of 1. So if I factor out a 1, you don't really need to write it, but I'll write it just so you can see what I did. You have x minus 3. So you can see that now my new greatest common factor is x minus 3. That parenthesis is going to come out in front. And then we're going to have x squared plus 1. And x squared plus 1 is our sum of squares. That's our special pattern, sum of squares. So we need to keep factoring that to x plus I and x subtract I. Okay, here we go. So this is we're gonna start into our rational expressions here. So first of all, we got to talk about a rule and a very common mistake. And so we want to highlight why we can't do this. So first of all, on the left-hand side, we've got a times c divided by b times c. So most of us want to go ahead and just reduce c. C in the numerator, c in the denominator, that reduces to 1, so then you just have a over b. That's true. That works. Okay, but it doesn't work over here if you have a plus c divided by b plus c. The tendency is for everybody to cross that out because we do it when we multiply. It looks so tempting to cross it out when we're adding, but that's not true. You won't get a over b. It's not a true statement. You can't reduce like that across an addition sign. Whatever's in the denominator has to be able to divide into the numerator. So it's easier if I show you with some numbers. So let me just make up some numbers and I'll show you how that works. So let's just say, for instance, that A is going to be 2, B is 5, and C is 9. I just made up some random numbers. Okay, let's go ahead and put those numbers in and see what happens. So right here, we're going to go ahead and put in 2 times 9, and then b is 5 times 9. Okay, well, let's just go ahead and multiply that out and not reduce it. Let's multiply it out and see what we get. So 2 times 9 is 18, and 5 times 9 is 45. Okay, let's reduce that fraction. So yeah, they're both divide by 9. What do we get? If we reduce the fraction, we end up with 2 over 5. And is that what A is? Yep, A is 2 and B is 5. So that is true. That works. Let's come over here and show why it doesn't work across addition. So we're going to put an A right here is 2, C is 5, and B is 5, and C is, oh, whoops, I did the wrong one. C is 9, not 5. Sorry. Let's fix that. So C is 9, and down here, 5 plus 9. Okay, let's add those two together. 2 plus 9 is 11, and 5 plus 9 is 14. Does that fraction equal A is 2 and B is 5? Can this fraction reduce to equal 2 over 5? No, 11 over 14 is reduced. So you can see then it's not true to reduce the nines. That's not a true statement. You can't do that. You can't reduce across an addition sign. Okay, so this chapter, the big key is in order to reduce anything, you've got to have it in its factored form. So if I look over here on the bottom left, this very first one, I'm going to put parentheses around this x plus 1. That's going to be considered a grouping, and the x plus 2 is considered a grouping. Okay, we just talked about how we can't cross those x's out because of our addition sign. So since the x plus 1 is its own grouping and x plus 2 is its own grouping and they're not the same, then that answer is reduced. That's as much as that fraction will reduce. Okay, over here in the middle, I've got 3 times x, that's a times in the middle, and 4 times x. Okay, so would I be allowed to reduce those x's? Yes, those two are multiplied, that reduces, and you end up with 3/4. Okay, over here on the right, I'm not allowed to divide the 2 into the 4 and do, that's a cross. See, we got addition signs here. We can't do that. We can't cross out the x's. I've got addition sign in the middle. That's not true. We can't do that. So the only thing we can do is factor and reduce. Everything has to be factored first. Well, x plus 2 is factored. That's its own grouping. 2x plus 4, well, I notice there's a greatest common factor there of a 2. So I'm going to factor a 2 out and I end up with x plus 2. Okay, so now I've got 2 times x plus 2 over x plus 2. Okay, these are the same two factors. This factor is identical to this factor. So that's like 1 over 1. They can reduce. And so we end up with 2 as our final answer. So we have to factor and then reduce. Factor and then reduce. Okay, so now what we're going to do is it kind of goes along with the front slide of how we factor things. If we factor with the negative sign at the back end, or the variable at the back end, or the front end, what happens? When you're reducing, it's really important to be able to recognize, is this reduced to 1 or negative 1? So if we look at this first one, this is 7 times x and 7 times x. Those two are like terms. They reduce, and you end up with negative 1 over 1. And so negative 1 divided by 1 is negative 1. That reduces to negative 1. Over here, I see that I got an x plus 2 divided by an x plus 2. These two factors are the same thing, so I'm going to reduce that, and when I do, I end up with 1 divided by negative 1. I've got this negative sign in the bottom. Well, 1 divided by negative 1 is still negative 1. Okay. Over here, x plus 4 divided by a negative x subtract 4. Okay, well, those aren't the same, so maybe I take a GCF out of the bottom and write that as x plus 4, and negative times x plus 4, and we have x plus 4 on the top. So now x plus 4 is the same factor as x plus 4, so that reduces to 1 over negative 1. Typically, we don't leave the negative sign in the denominator, guys. So we would just go ahead and write 1 divided by negative 1 as negative 1. And over here, x minus 5 and 5 minus x. Are those two the same thing? They are not. Up here, the plus sign, x is positive. Down here, the x is negative. So they're not the same thing. And you can't just flip-flop them. That's not true. I can't write it like this and just switch the order of the bottom. That's not true. If I'm going to move the x, you have to take the sign that's in front of it. So if I wanted to, I could rewrite it, and I could say x minus 5, move the x out in front, plus 5. Um, but those still aren't the same thing. But what if I factor out a negative 1 out of the bottom? So if I take out a negative, then I've got x minus 5, which is now the same as the top, and we end up with 1 divided by negative 1, which is still negative 1. But that's a lot of extra work, so it's really nice. You can cut down on the factoring, guys, of taking out the negative sign. I mean, if you want to do that, you can. If it helps you understand it better, you can. But I personally like to just look at it and recognize, okay, this sign is a plus, this sign is a minus. Those are opposite. This sign is a minus and this sign is a plus. Those two are opposite. So everything, so the signs in the numerator are all exactly opposite of every sign in the denominator. If that's true, then it's always going to reduce to negative 1. Now, if they were exactly the same, it would reduce to 1. And if there was some kind of partial identical signs, then that would be a neither. So that's what we're going to do on this slide right here. We're going to see if we can tell just by looking at things. We can rearrange if we need to, but we kind of want to get to the idea. Can we look at it and tell if it's going to reduce to 1, negative 1, or neither? So on this first one right here, I'm looking at it, x minus 1 and 1 minus x. Those are not the same thing, so I definitely know it's not going to be equal to 1. But I'm going to take a closer look. Sign in the numerator here is a positive, and this one is a negative. Let's go look and see how it compares in the denominator. Well, the x is negative and the 1 is positive. They're exactly opposite. So all of the signs in the numerator are exactly opposite of all of the signs in the denominator, so that means it will reduce to negative 1. So can we do that and show that algebraically? We can, but remember, our goal is to be able to look at it and identify that. So you could rearrange it and then factor out the negative, and now you can see that that's the same as that, and that still reduces to negative 1. Okay, but our goal is to be able to look at it and tell. So let's look at this next one. X plus 2 divided by 2 plus x. It looks like to me all of the signs, everything looks identical, so this will be 1. Just because they're in the opposite order, you could rearrange this one on the bottom and make that x plus 2. And x plus 2 in the denominator and x plus 2 in the numerator equals 1. Okay, next one over. We've got x minus 3 over x plus 3. Well, we've got x's have the same sign and the 3's have opposite signs. So this is kind of a partial. Nothing is exactly the same and nothing is exactly opposite. So this is going to be a neither. The signs have to be exactly the same in order to reduce to 1 or exactly opposite to reduce to negative 1. Okay, let's look at this next one. So in the numerator, it looks like I've got x squared minus 1, and in the denominator, I've got 1 minus x squared. So it looks like to me the signs are exactly opposite. So that's going to be negative 1. Over here, x plus 3 quantity squared, and in the bottom I've got x squared plus 6x plus 9, but I do know that x squared, or x plus 3 quantity squared, is the same thing as multiplying out x plus 3 times x plus 3. And if you do that, you end up with x squared plus 6x plus 9. Okay, and that's exactly the same as what the bottom is, so that would equal 1. All right, the next one, I notice I've got a positive 3 in the numerator, positive 3 in the denominator, x plus 4 here, x plus 4 here. Everything looks the same, so that's going to reduce to 1. Those are going to reduce, and those are going to reduce. So that reduces to 1. V squared minus 1 over v squared plus 1. Once again, we've got partial. They're not exactly the same or exactly opposite, so that's a neither. This one right here, a negative x minus 3 over x plus 3. Those two look like they're exactly opposite to me, so that's negative 1. We could prove that by factoring out the negative sign. And then there we go, and we end up with negative 1. Okay, down here on the bottom, it looks like to me this one is a negative x, and that's a negative x. Positive 3 here, positive 3 here. So it looks like to me all the signs are exactly the same. That's going to equal 1. Let's rearrange it, and you can see that they are indeed the same. What if I take the bottom one and I put the negative x out in front? So I move this term to the front, and then I put plus 3. Now you can see the denominator is exactly the same as the numerator, and that equals 1. Okay, next one, y squared plus 1 divided by y1 plus y squared. Once again, those are identical in sign, so that's 1. The third one over, we've got positive signs, but then look, these two are opposite. So we've got that partial again, where everything's the same and then something's different. So that's a neither. Okay, fourth one. When I look at this, I could rearrange it if I wanted, right? Negative x squared plus 2x plus 3. Okay, let's compare numerator to denominator. Negative x squared on the bottom, positive on the top. Positive 2 on the bottom, negative on the top, and positive 3. It looks like everything's exactly opposite in sign, so that would be negative 1. A minus B and a negative A plus B. So these two are opposite. The A's are opposite and the B's are opposite. So that would be negative 1. Next one, they look identical to me, even though they've put the x squared at the back end. If you rearranged it and put it in descending order in standard form, you could see they're the same. So this is 1. 5 minus x over 5 minus x, that would be 1. And then once again, x plus 3 quantity squared is the same thing as x squared plus 6x plus 9, and that is not identical to x squared plus 9. So that one is a neither. Okay, so being able to recognize if something reduces to 1 or negative 1 is going to be a good skill as we go through this chapter. This one is just more practice. Can we see what's equivalent to each other? Especially when you're taking multiple choice tests, you might write an answer one way and then not find it, but yet an equivalent answer could be there based on where the negative sign is. That's the thing with fractions. You could factor out negative signs and put them out in the middle. You could leave them in the top. So you can end up with equivalent answers. So you got to be able to recognize that. So this one says, circle the expressions that are the same and place an X over the oddball expression in each row. So if you guys are Sesame Street fans, they used to do this thing in Sesame Street where they would look for, one thing is not like the other, which one doesn't belong. That's kind of what we're doing. So they're all equivalent except for one, but yet they all look a little bit different in how they're written. So we kind of have to figure out which one is different. Okay, so when we look at number 2, first thing I notice here is this first one has a negative sign out in the middle and none of the other ones do. So I think I'll move the negative sign up to the top right here. And as soon as I did that, it looks like to me a negative x minus 3 over x minus 4 is the same thing as this. These two are the same. Okay, so that means my oddball out has to be one of these. All right, so let's see. What would have happened if, let's see, we've got negative x minus 3, and then this one right here is a negative x plus 4. This one right here, this numerator matches, but this denominator does not match right there. So I'm thinking this is the odd man out. Let's come over here and see if we could get this one to look like that on the bottom. So what I'm thinking is, what happens if we factor out a negative from the bottom? So that would be negative and then x minus 4. But remember this negative sign right here, we can move it out to the middle if we need to, or to the top. So if I move it out to the middle, then it looks just like the original one on the first column. So this one is the same. So yep, this was the odd man out. This one was the one that was different. Okay, kind of getting the idea. So this next one, number 3, when I look at it at a quick glance, I see this third one over has a negative sign out in the middle. So what would happen if, it looks like to me all the tops have x minus 5s in them. So I'm going to take this negative sign. We don't normally do this, but just for practice for trying to recognize equivalent things, I would move this one down to the bottom. And so now this becomes x minus 5 over negative x plus 5. Okay, so let's see. X minus 5. These two now look identical. Okay. And then this one right here would be the same thing because I could rewrite it, and it would be negative x plus 5. And it matches the same. So this one's different. X minus 5 over x minus 5. That reduces to 1. And maybe some of you looked at it and were like, oh, look, these are one negative ones. And you could see that these were exactly opposite. They were all negative ones except for that one. That one was positive one. We could look at it that way also if we wanted to. Okay, so let's look at this next one. We've got this negative sign here. So if we move this negative sign to the new, it looks like to me, oh, I've got two of them that got a positive x plus 4 in the numerator. These two right here are the same. Okay, so I know those two are the same. So what I'm going to do is I'm going to move the negative sign to the, let's see, on this one, I think I'm going to move it to the denominator. And then we would end up with a negative x minus 4 over x plus 4. And then over here, I'm going to move it to the numerator. And that's going to leave you with x plus 4 over x plus 4. And so that's the same as the other one. So this is odd man out. That one's different. Okay, this next one, x plus 1, x plus 1. It looks like on the top they're all x plus 1. So for this first one, I think I'm going to move this negative sign down to the bottom. And remember, like I said, just for this exercise, normally we don't do that. But if you were trying to figure out equivalent answers, then that would be something you could do. Normally we like the negative sign to be in the middle or the top. So we've got x plus 1 over a negative 1 plus x. Okay. I feel like that's the exact same thing as this one right here. I could rewrite this to say x plus 1 and negative 1 plus x. So these two are the same. And same thing with this one. I don't know why I'm writing the negative 1 first. X plus 1, we could write that as negative 1 plus x, rewrite it. And so that's the same. So then this one's the odd man out. That one's different. Okay, bottom row. Let's factor this and see what we end up with. X plus 3 and x plus 1. Okay, then this looks exactly the same as this one. This one right here factors to the exact same thing, x plus 3, x plus 1. And this one, x plus 3, x plus 1. Move this negative sign up here, and this turns out to be x minus 4. So this one's the same as the other two. This is the different one, 4 minus x. Okay, so those negative signs, guys, you've got to be able to work with them, and you've got to be able to manipulate them around and make equivalent statements. So the negative signs are important. All right, so now we're going to put that into use. We're actually going to go ahead and start reducing these expressions. So remember, our goal here is to simplify. And so basically, since we've got fractions, what we want to do is we basically want them in factored form. So what I say mostly in this chapter is factor and reduce. So this chapter, the biggest thing is going to be factoring. So if you get stuck and you don't know how to start the problem, you could start by factoring. Question number 1 is already factored. You've got 8, it's not prime factored, but you've got 8 times x to the third times y times 7 times x to the fourth times y to the third, 2 times x times y squared times 4y. So that's all factored. There's only multiplication in that statement. That's all factored. We did this type of a problem clear back in chapter 1 when we were doing our exponent rules. So the thing about this one is there's many different ways that you can approach this one. You could do straight across the top. So I could do 56, x to the 7th, y to the 4th, over, and then do straight across the bottom, 8, xy to the 3rd. And then I could reduce that, and I would end up with 7, x to the 6th, y. So I could just do that. I could, some people like to just start reducing. I could say, well, 2 goes into 8 4 times. This 4 reduces with that 4. This y is going to reduce with that y. This y squared will reduce with this y to the third and leave us with a y. This x reduces with this x to the third and gives us x squared. And then we've got everything crossed out, and what are we left with? We're left with x squared times 7 times, so this is what we've got, x squared times 7, x to the fourth y. Well, one last step, and we get 7, x to the sixth y. So like I said, there's more than one way to approach that one. Whatever you're comfortable with, there's more than one way. Okay, this one. So this is a no-no. Remember, this is exactly what we cannot do. We can't just start crossing things out because it's not factored. We can't reduce it until it's factored. So what we're going to do is factor the numerator. So that's going to go to x plus 3 times x plus 2. Factor the denominator. So it looks like to me it's the greatest common factor of an x, and that will be x plus 3. Now, this is the fun part. Now you look for the same factors that are in the numerator and the denominator. They both have an x plus 3. That grouping symbol is the same factor. That can reduce. So what are we left with? X plus 2 over x. And once again, are we allowed to cross this out like that? No, we are not. This x has to divide, this kind of looks like that triangle we talked about earlier. It has to divide into both pieces, not just the x. So we have to leave it x plus 2 over x. All right, number 3, factor. I've got x squared plus 5x over x squared plus x. I can't reduce it until I factor. So GCF at the beginning and GCF on the bottom. Okay, what factors are the same in the numerator? See how I have x times this parenthesis and x times this parenthesis? The groupings we could reduce if they were the same, but they're not. But these x's are the same, so I can reduce those. And our final answer is x plus 5 over x plus 1. I kind of like these. I don't know why. I find it very satisfying to factor it all and then just start crossing things out. Okay, let's look at number 4, x squared minus 2x minus 5. So we're going to say factor that, and that's going to go x minus 5 over x plus 3 over, now, there's 2 ways you can factor this. This is like our bell work. We can leave the x squared at the back, so I'm going to factor it as x, excuse me, I'm leaving it at the back, so I'm going to factor that as 3 and 3, x and x, plus and minus. Okay, so is x plus 3 the same thing as x plus 3? It is. So what do we end up with? X minus 5 over 3 minus x. Okay, but let's say that you didn't like that. You don't like factoring with the x at the back end, and you rewrote it. So you rewrote it so it looks like this: x squared minus 2x minus 15. And then you did a minus x squared plus 9. And then your next step was you factored out. So I'm going to factor out that negative and make that x squared minus 9. And then I'm going to factor that to x plus 3 and x minus 3. And then in the numerator, this factored to x plus 5 and, nope, x minus 5 and x plus 3. Okay, let's write down here what we have because I've done a lot of factoring. That one went away, that one went away, and that one went away. So what we ended up with was x minus 5 over x plus 3, and then a negative and x plus 3 over x minus 3. Okay, those x plus 3's can cross out, and we're left with x minus 5, parenthesis, and then a negative, and then x minus 3. Okay, so typically we don't leave a negative sign out here like this. So either we have to move it to the top or we have to distribute it through the bottom. So if you were looking, if this was a multiple choice test and you didn't see this answer here, x minus 5 over a negative, then you would do one of two things. You'd either move it to the top and you'd look for this answer. Okay, you would move the negative sign to the top and you'd look for that answer, or you'd move the negative sign, you distribute it in the bottom and you'd look for this answer, which is negative x plus 3, which is the same as what we have over here on the left. Okay, so those are all equivalent answers. You have to be able to identify that. Okay, so number five, yeah, we've got 4 minus x over x squared minus 4. So 4 minus x, that looks factored. X squared minus 16, oh, I said that wrong. X squared minus 16 is difference of squares, so that's x plus 4 and x minus 4. Okay, so here's where our idea of can we recognize opposites? If we can, you would recognize that this 4 minus x and this x minus 4 are opposites, and that reduces to negative 1. And so my answer would be negative 1 over x plus 4. Okay, but let's just say we didn't recognize that. Let's go back here to this step, and we have 4 minus x over x plus 4 and x minus 4. Okay, what could you do in the numerator? You could rearrange it and factor out a negative sign. So you could put the negative sign out in front and go x minus 4, and then x plus 4, x minus 4. And once again, these two are going to reduce, and you end up with negative 1 over x plus 4. So if you want to rearrange it, you can. It's nice, it's shorter if you can identify what's equivalent to 1 and negative 1. The one thing that you have to understand is that 4 minus x is not the same as x minus 4, so you can't just cross them out. You have to show that it reduces to negative 1. All right, now we've got two fractions that we're multiplying together. Well, same scenario as before. We still need to get it all in factored form. So basically we're saying the whole top times the whole bottom. Let's factor it. So the numerator, I think I'll factor out a 3x. And that'll give us 1 minus x in that first parenthesis. And then on the denominator, it's going to be x plus 5 times x minus 1 times, and then the other fraction is going to be x plus 5 and x minus 4 over 3x. Okay, so remember, anything in the numerator can reduce with anything in the denominator. It can reduce diagonally or up and down. You just can't reduce left and right. So this is diagonally, so these two could reduce. The x plus 5s could reduce. And now I want to take a closer look at this 1 minus x and this x minus 1. They are not the same, but they do look exactly opposite, so I feel like those are going to reduce to be a negative 1. So if they're exactly opposite of each other, we can reduce that and make that negative 1. So what am I left with? I'm left with negative 1 times x minus 4. So we would go ahead and do the distributive property on that, and you'd end up with a negative x plus 4 for your final answer. Okay, number 7. Same thing. We've got two fractions being multiplied together. Before we can reduce it, we've got to factor it. So factor and reduce. So we're going to say x plus 3, x plus 1 over x plus 3 and x plus 2 times x minus 5 and x plus 2 over x times x plus 1. All right, everything's factored. So fun part, we start crossing out all those same factors. So this x plus 1 and that x plus 1, they're the same. This x plus 2 and that x plus 2, they're the same. X plus 3 and x plus 3, they're the same. So what are we left with? We're left with x minus 5 over x. And remember, we can't cross out the x's because the x minus 5, that's subtraction, that's not multiplication. We can only reduce when everything is multiplied together. This sign right here, if it had been a plus sign, then we couldn't have done what we were doing. That's a whole nother problem, that's a whole nother lesson. but everything's being multiplied, so we can start reducing. Okay, division. We have learned over and over again that division is the same thing as multiplying by the reciprocal. So when you see your division sign right here, you are going to change that to a multiply by the reciprocal, and you take the reciprocal of what follows the division sign. So the reciprocal of this statement right here, not the one in the front, the one at the back. Whatever follows the division sign is what you do the reciprocal of. So my problem would be 7x over 2x minus 10, division, same thing as multiply by the reciprocal, so times x squared minus 11x plus 30 over x squared minus 6x. Perfect. Okay, now we're going to start factoring and reduce and see what happens. So this is going to be 7x, and then I'm going to factor out a 2, so x minus 5, times 30, I'm going to do 6 and 5. So x minus 5 and x minus 6 over x times x minus 6. Okay, fun part, start crossing out those like factors. That x minus 6 goes with that x minus 6. That x minus 5 goes with that x minus 5. And remember, right here, this 7x is not grouped together. This is 7 times x. So I'm allowed to reduce this x with that x. And that leaves us with just the fraction 7 over 2. Okay, next one, 9x squared over 3 minus 6x multiply by the reciprocal. So 2x squared minus x over 3x squared minus 12x. All right, and now we're going to go ahead and factor those. 3 minus 6x, that's going to factor out with a GCF of 3. And then times, we're going to factor out an x, so that's going to be 2x minus 1. Factor out a 3x, and that's going to be x minus 4, like that. Okay, so this one is a little harder to see what's identical factors. Once again, though, I'm noticing this 2x minus 1 and this 1 minus 2x. Those look exactly opposite to me. They're not the same, so I can't just cross them out. Because they're exactly opposite, I know it's going to reduce to negative 1. And I usually put the negative 1 in the numerator, because remember, that's usually where we want everything to be, our negative signs. So I put that in the numerator. Okay, so now I do have an x here and an x here, so I could reduce those two. That's okay. But that leaves me with, so what are we left with? I'm going to rewrite what we're left with so we can see what's going on. We've got 9x squared times negative 1. So I'm left with negative 9x squared over 3 times 3, which is 9. So it looks like to me I can reduce the 9's, and we end up with a negative x squared as our answer. Okay, and then these right here, these last slides are just, I'll just go through them. They're just in your homework, you have some geometry problems. So in case you couldn't remember the formula for a sphere, there it is. Formula for a pyramid. This right here, B, represents the area of the base of your pyramid. So that would be the area of this piece right here, times how high it is. Okay, and then this one is the cylinder. So the base of a cylinder, remember, is your circle. It's the area, so this is the area of the base. And the area of the base is a circle, and so the area of a circle is pi r squared, in case you've forgotten. And then here's a cone, so same thing. The base of the cone is a circle. So that represents the area of the base. And so once again, you'd put the area of a circle in there. So you'd figure out what the area of the base is and then multiply it by 1/3 and its height. Okay, we're done.